Welcome to the 14th episode of AI Talks with Chris and Nita. We hope that the new year is going on well for you. Today we're diving into the fascinating world of deep learning and specifically a technique you've been researching called Dropout Regularization.
It's one of those tools that seems counterintuitive at first, but once you understand how it works, it's truly elegant.
That's what I'm hoping for.
Yeah.
I understand the basics of overfitting, how a model can essentially memorize the training data and then fail when it encounters something new. But how does Dropout help with that? It sounds almost like it's making the model worse during training.
That's the beauty of it. By randomly switching off a portion of the neurons during each training step, Dropout forces the network to learn more robust and generalizable features.
So it's not relying on any single neuron or pathway too heavily. It's more like a team effort where every neuron has to be ready to contribute.
Exactly, and this is where the ensemble effect comes in. Dropout essentially simulates training multiple smaller networks simultaneously and then combines their knowledge. Think of it like getting multiple expert opinions instead of just one.
Okay, that makes sense. So Dropout helps prevent overfitting by introducing this randomness and forcing the network to learn more generalizable features. But are there any downsides to using this technique?
Well, one thing to consider is that Dropout can increase the time it takes to train the model. After all, we're essentially adding complexity to the process.
So it's a trade-off between accuracy and training time.
Precisely.
Okay.
And it's important to weigh those factors based on the specific application.
Right.
If you have limited computational resources or a tight deadline,
I see.
Dropout might not be the best choice, but in many cases, the improved performance gains far outweigh the extra training time.
That makes sense. And what about optimizing Dropout? Is it straightforward to implement and tune?
Well, that's where things get a bit tricky. Dropout introduces new parameters like dropout rate, the probability of a neuron being deactivated, and finding the optimal dropout rate often involves a bit of experimentation.
I can imagine. It's probably not a one-size-fits-all situation.
Exactly. The ideal dropout rate depends on various factors, like the size of the network and the nature of the data. There are techniques like grid search or random search that can help systematically explore different parameter combinations.
So you need to carefully choose the dropout rate to get the best results. But once you find that sweet spot, it can significantly improve your model's performance.
Absolutely. It's a powerful tool that can make all the difference in building robust and reliable deep learning models.
You mentioned that Dropout can be applied to different types of layers in a neural network. Can you elaborate on that a bit?
Sure. You can use Dropout in fully connected layers, convolutional layers, and even recurrent layers. Essentially anywhere where you have neurons that could potentially become too specialized or reliant on specific features in the training data.
But there's one exception, right? You never apply Dropout to the output layer.
That's right. The output layer is where the final predictions are made, and we don't want to introduce randomness there.
It makes sense to keep that final step deterministic.
Yeah.
So we've covered the basics of how Dropout works, its advantages, and some of the potential drawbacks. But I'm curious what specifically about Dropout regularization sparked your interest and led you to research it further.
Well, I was particularly drawn to the research you sent about its applications in medical image analysis. The idea that Dropout could help improve the accuracy of detecting tumors in mammograms is incredibly compelling.
That's right. The research I sent highlighted how Dropout not only improved the model's overall accuracy, but also reduced the number of false positives.
That's a crucial point. In medical diagnoses, false positives can lead to unnecessary anxiety for patients and potentially even unnecessary procedures.
Exactly. And it's fascinating how these seemingly abstract mathematical concepts can have such a tangible impact on people's lives.
It really underscores the potential of deep learning to revolutionize healthcare.
You mentioned earlier that Dropout makes the network more resilient and adaptable. Can you elaborate on that?
Sure. Imagine a neural network where one particular neuron becomes highly specialized at detecting a very specific feature in the training data.
Like a neuron that's really good at spotting a certain shape that's indicative of a tumor.
Exactly. Now, what happens if that specific shape is slightly different in a new image, or if there's noise in the image that obscures the shape?
The neuron might fail to detect the feature, and the model could make an incorrect prediction.
Precisely. But with Dropout, the network is less likely to rely solely on that one specialized neuron. Because neurons are randomly dropped out during training, the network is forced to learn alternative ways to represent the data.
So it's like having a backup plan. If one pathway is blocked, There are others that can step in.
Exactly. And this redundancy is what makes the network more robust and less susceptible to variations or noise in the data.
That makes sense.
Yeah.
So dropout isn't just about preventing the network from memorizing the training data. It's about teaching it to learn the underlying patterns in a way that can be applied to new situations.
Absolutely. It's about promoting generalization rather than memorization.
Okay.
And that's why Dropout has been so successful across a wide range of applications.
It seems like dropout is this crucial ingredient that can elevate the performance of a deep learning model.
It can be, yes.
Yeah.
But as we've discussed,
Right.
there are some challenges associated with it, such as increased training time and the complexity of optimization.
You mentioned that understanding why dropout works is still an area of active research. What are some of the current theories and hypotheses about its underlying mechanisms?
Well, one theory is that dropout acts as a form of regularization by preventing the co-adaptation of neurons.
What does co-adaptation mean in this context?
It refers to a situation where neurons become too reliant on each other's activations.
Okay.
They start to specialize in a way that's very specific to the training data,
Right.
which hinders their ability to generalize to new data.
So dropout is breaking up these codependencies, forcing neurons to learn more independently.
Exactly. By randomly dropping out neurons, we're preventing them from becoming too entangled with each other.
That's fascinating. It's like dropout is encouraging a more diverse and independent set of opinions within the network.
That's a great way to put it.
Yeah.
And this diversity of perspectives is ultimately what contributes to the model's improved generalization capabilities.
Okay, that makes a lot of sense. So dropout disrupts these co-adaptations, forces neurons to learn more independently, and ultimately leads to a more robust and generalizable model.
Precisely.
Hmm.
And another interesting theory is that dropout might be mimicking a biological mechanism that occurs in our own brains.
Oh, that's intriguing. How so?
Well, there's evidence to suggest that our brains also employ a form of dropout to prevent overfitting and promote generalization.
You're saying our brains might be randomly silencing neurons during learning?
There's research that supports this idea. For example, studies have shown that certain neurotransmitters can inhibit the activity of specific neurons,
Right.
effectively dropping them out of the network.
That's mind-blowing. So this technique that we're using in artificial neural networks
Yeah.
might actually be mirroring a natural process that occurs in our own brains.
It's a fascinating possibility. And it highlights the deep connection between artificial intelligence
Right, yeah.
and the study of the human brain.
It makes you wonder if we can glean even more insights about how our own minds work by
Yeah.
studying techniques like dropout.
Absolutely. The field of AI is not just about building machines that can perform tasks. It's also about gaining a deeper understanding of intelligence itself,
Okay.
both artificial and natural.
That's a powerful thought. So we've covered the technical aspects of dropout, its advantages,
Ugh.
its challenges, and even its potential connection to the human brain.
Yeah.
We've also dived into the specifics of your research and seen how dropout can be applied to real-world problems like medical image analysis. I want to bring it back to the research you sent. What specifically about the application of dropout in medical image analysis intrigued you?
Well, what really struck me was the potential impact on early and accurate diagnosis. As we discussed, false positives can be a significant issue in medical imaging, leading to unnecessary stress and intervention. The fact that dropout can help mitigate that is truly remarkable.
It is, and it speaks to the importance of robustness
Yeah.
and generalization in these types of models. We need to be confident that they can perform reliably on a variety of cases, not just the ones they were specifically trained on. And I was particularly fascinated by how they integrated dropout into the specific architecture of the convolutional neural network used for mammogram analysis.
Right.
It wasn't just a generic application. They really tailored it to the task at hand.
That's a key point. The success of dropout often lies in the details of its implementation. How you choose the dropout rate, which layers you apply it to, and how you integrate it with other regularization techniques can all make a difference.
It's like fine-tuning an engine. You need to adjust all the parameters just right to get optimal performance.
Precisely. And that's where the art and science of deep learning come together.
Yeah.
There's a lot of experimentation and intuition involved in finding the best configuration for a specific problem.
So it's not just about understanding the theoretical concepts, it's also about having that hands-on experience to fine-tune these models in practice.
Exactly. And that's why I encourage everyone who's interested in deep learning to get their hands dirty and start experimenting with these techniques. There's no substitute for practical experience.
Well said. So we've explored the ins and outs of dropout regularization, how it works,
Yeah.
its advantages, its challenges, even its potential connections to the human brain. We've also dived into the specifics of your research and seen how Dropout can be applied to real-world problems like medical image analysis.
And hopefully this deep dive has not only deepened your understanding of Dropout, but also sparked a curiosity to explore other advanced techniques in deep learning.
Absolutely. It's the field that's constantly evolving, and there's always something new to learn.
That's the beauty of it.
Yeah.
So to our listener, keep exploring, keep experimenting, and keep pushing the boundaries of what's possible with AI. Who knows, maybe one day you'll be the one sharing your groundbreaking research with us.
That's a great note to end on. Until next time, keep that curiosity alive and keep on learning.